In this video, we're going to do the while loop as a lab. A while loop is just like a for loop. They are ideal for some tasks that repeat themselves again and again. So each task maybe change a little bit of the numbers or something, but it's basically repeat itself. So the general format of a while loop is a while, and then you have a condition, and then you have some statements, and then you have else block, and then you have a final code for the statements. Here's the first example for the while loop. When x equals to 0, so the first step is x is assigned with is 0, and then while x is less than 10, then you first print out what's the current value of x, and then you are going to just to show what is x is less than 0, adding 1 to x, then x plus equals to 1. This basically means x is increased by 1. So x will be equals to x plus 1. Okay, this is the statement. So now x becomes 1. Then we go back to the condition. The 1 is still less than 10. Then we test this. We're going to execute this block of code. So x is currently 1, and x is still less than 10. Add 1 to x. Then x increased by 1 again. This will make x as 2. 2 is less than 10, and then we execute this again. So you will notice that this piece of code is actually repeatedly be executed. So let's run this code. You're going to find it. That's the results. So x equals to 0, and then after this one, we increase by 1, and it becomes 1. And I keep on doing that when the last one is actually x equals 9. So we just printed that one, x is 9, and then we printed this 9, and then x increased by 1. That will make x equals to 10. 10 is less than 10 is false. This expression is actually false. So that will terminate the whole while loop, and then execute the code right below the while loop. So in this case, we don't have any code, so it's not executed anymore. Another example is suppose we're making a temperature. The temperature first was 0. So if the temperature is not negative 1000, then we will ask the user to enter a temperature, and then we will print the Fahrenheit. So this is a Celsius, and this is Fahrenheit. Else is when we are done with the while loop. If we have some cleanup work, we can put it right here. So let's run this again. So you will notice it's asking me to type something. Let's say 30 degree. It's going to be 86. 20 degree. It's going to give me 68, right? And then I can type 10. It's going to be 50, right? So if I type negative 1000, what will happen? Then I am going to get negative 1000, and this one will be still executing. However, when we finish the executing of this one, it's coming back to the condition. We're going to test that because this will be equal. This will be false, right? Negative 1000 is not equals to negative 1000, is false. So that will actually come back right here, go to the else clause, and then do the print part. So if I just strike enter key on my keyboard, it will tell me it's actually all done, right? All done. So this is about the while else loop. The next part is we can actually somehow change the flow of the while loop by using 3 keywords: break, continue, and pass. So break actually will break out the structure, while continue will goes to the top of the loop, and pass does nothing for this step, for this moment. So it does nothing at this moment. Sometimes when we write some programs, we haven't figured out what to do for that part yet. We can leave a pass right there. So it's different to those two. Okay, break and continue, they're different. All of the three are different. Okay, so let's take a look. So in this one, you're gonna say, okay, I have a x is assigned with 0, while 0 is less than 10. So this is true condition. Then I'm going to execute all the code down here. So I will execute the first one, printed out the current value of x is 0, and then print out the whole thing, add by 1. So x now becomes x equals to x plus 1. So x becomes 1. And if x equals to number 3, x1, right? X is 1, 1 is equals to 3, that's false. That's false. It's going to print out this continue, and then here you have continue. Then come back to the top of the loop. So that's will be the condition. Now 1 is less than 10, so which is also true. Then we're going to go this again, and then here x equals to x plus equals to 1, x becomes 3. Now we test this condition, 3 is equals to 3, then that will make this as a true condition, and then we are going to execute this print x equals to 3. And we don't need to type this again, right? Because that's the else part. Then we come back to the condition again. Now x3 is less than 10, and then we increase by 1, and this will be false. We print out this, and then we come back here, 5. So you're going to only see one x equals to 3. All the rest will be all the continues. So if we execute, you're going to see the results. So x equals to 0, continue, and here is x equal to 3. And then all the rest are all continues, right? All the continues. So for that one, now let's change that by adding a break to the loop. So everything else stays the same except when x equals to 3, we add a break. So this one will actually terminate the whole loop. So you're going to see we only see up to x equal to 3. So this is x equals to 0, and then 1, 2. When x equals 3, this actually breaks because x equals to 3. So that's the break. Sometimes we got to be careful when we are actually using the condition. If the condition is always true, it's a tautology, then we got to be very, very careful, because that means we are constructing an infinity loop. So like in this example, you have while true, and then you are continue printing this, I'm stuck in the infinity loop. There is no way you can come out. It will keep on printing this. It says a word of caution. However, it is possible to create infinity loop with the while loop statement, for example this one. So if we run it, you're going to see that we actually stuck right there, and we have no way out. See, let's keep on printing that one. Let's keep on printing. See, we're keep on printing. Yeah. You see, we're keep on printing. Then how do I stop it? You can click this one, stop the kernel. You're going to stop the kernel first, and then you're going to restart the kernel. Restart the kernel and restart. That will make it work, okay? That will make it work. Otherwise, you're going to see this, I'm stuck in a loop. Oh, did I type something right here? Yeah. So sometimes be careful when you are using that. so in the past, we actually were asking you to do a guess game. Here now we can do a much nicer guessing game. In this one, we're gonna do give you some the user some hint. For example, I'm writing this guessing game. So we first use a computer to generate a random integer between 1 to 100, and then we have a variable to store the number of attempts, and then the actual guess of the user. So first we're going to test if the guess is not equals to the secret number, and the user still have several shots, right? Attempts is less than or equal to 4. Then we will first take the user's guess and then increase the number of guesses by 1, and then test if the guess number is less than secret number. That means the guess number should go higher, right? Should go higher. Then print out how many guesses left, and if this guess is greater than else if the guess number is greater than secret number, then we print you should go lower, and the number of guesses left is printed out too. Otherwise, that means you got it, right? You got it. And then if you got it, then the guess should equals to this, right? So this one will be a force. So you have a force. No matter this is true or false, the whole expression is going to have force value, and then the while loop will be terminated, and then you're going to execute the line right below the while loop. So that will be this line, and then so the number of guesses equals to number 5, and this guess is not equals to the secret number, then you just print out that you lose. Since you just guessed it correctly, so this will be false statement, then this line will not print it out. Okay, so let's go ahead and play with this code. Let's see what it's gonna be. So apparently right now it's just pop up right this line, right? That means I already have a computer generated secret number. What I'm gonna do is make a guess. So my best strategy is going to be using the binary search. So I'm searching one number in a series of number between 1 to 100. I need to find what particular number the secret number is, right? So I'm going to first try 50. This is called a binary search. It says I should go lower. Then I'm going to try 25. And it says still go lower. So this number must be between 1 to 25. So between 1 to 25, I can do either 13 or 12. It's actually 12.5. So I'm going to do 13. And it says it's going to be higher. So it's between 13 to 25. So it's going to be, what's the middle? So middle will be roughly about 17, am I right? So, yep. No, actually, 19. Roughly, it's about a 19, right? So the middle number roughly is going to be 19. So I'm going to type 19. So this says it should go lower. That's between 13 and 19. The number should be between 13 and 19. Now you see I'm actually lower down to a much smaller space to find the number. So the middle number roughly about should be around somewhere close to 16, right? So I'm going to type 16. Yep, so you see I actually get you got it, right? So I guessed it correctly. And what I used is called a binary search. Binary search, I used 1, 2, 3, 4, 5. I used it 5 times. I searched it. In the worst case, I probably, no matter what, if you give me 2 more chances, I should be able to find any number. Because 100, if you take the log 10, log based on 2. That would roughly, it's about what, 6 times, right? 5 or 6 times. You should be able to get everything. 2 to the power of 4 is 16. 2 to the power of 5 is 2 to the power of 4 is 16. 2 to the power of 5 is 32. And then 6 is 64. 7. Yeah, at most 7 times we should be able to find any number. So right now I spend 1, 2, 3, 4, 5. So I have pretty good chance. 5 times 5 over 7 that means I roughly have 80% success rate, right? 5 yeah, somewhere close to between 70 to 80% success rate. So this is a relatively easier to guess. So that's a good one. So go ahead and practice this and see if you can write a program like this, okay?